So, yesterday we did vertical stretches. Today we're going to do vertical slides, okay? So, let's make sure we haven't forgotten what we did yesterday. If I gave you something such as this, y equals -3, I'll do 2 review questions. Sine of theta, and if I asked you for, let's make it 3 sine theta, and y equals -5 secant theta. If you could do these two, you could do anything that we did yesterday, I think. So, I want to make sure, and I don't want to sound being picky here, but I'm trying to make it easier for you guys. When you're graphing these, the first thing you should do is this. Well, it's 3, so you put 3 to -3. And then when you're putting your hash marks on here, it's really important that you make them pretty darn close to evenly spaced. If you don't evenly space them, it makes it harder for you, okay? And I would not put them like, here, 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 and here. I would go all the way to the end and put 2 pi, all the way there. Then chop it in half and you have 1 pi. Between pi and 0, it's pi over 2. And between pi and 2 pi, it's 3 pi over 2. Okay? You got to have those, okay? And those will not change yet. They will eventually, but not yet, okay? And if you don't have it memorized right now, it's okay, but you really need to memorize it the next day or two. A sine wave starts right in the middle, okay? A cosine wave starts either the top or the bottom, okay? So it starts right in the middle, halfway through we're in the middle, and all the way in we're at the middle. And at pi over 2 we're at the high point, at 3 pi over 2 we're at the low point, and there's our graph. Now I'm going to make this a 2-parter. What if it was -3 sine theta? You would still have this point, and this point, but it would be down here and up here. So it would look more, I'm going to make it a dotted one here. Okay? That would be a negative sine graph. Actually, I'll make it a 3-parter. If this was a cosecant graph, we would have still done our sine graph. We still would have done that. But wherever it's touching the x-axis, we put a vertical asymptote here, a vertical asymptote here, and a vertical asymptote here. And a cosecant graph, it's going to go away from it and away from it. And if it was a negative cosecant graph, it would have been this one. And that one, that looks terrible, but you get the point, I think. Okay, I actually did 4 parts on that. Okay, any question on that? Now, if I had a secant graph, I'm going to put underneath that cosine. In order to do a secant graph, I've got to do a cosine graph first. Okay, so we're going to start out the same way. We're going from 5 to -5. We're going as far as 2 pi. Halfway through is pi, pi over 2, 3 pi over 2. Does a cosine wave start right in the middle? No, it starts at either the high point or the low point. Now, I don't think I've ever said this. In this case, is it going to start at the high point or the low point? The low, why? Negative flips it. It starts down at the low point. It's going to be down here, and it's going to end in the same spot. Halfway through, we're going to get the high point here and here. And you connect them not with a V, and it doesn't go, I see students connect it almost like a parabola. It's not like that either. It's not a parabola. It should actually arc in, then out, out, or in then out again. Okay, like that. And if I made it well, that's what I want is a secant graph. So we draw an asymptote here and an asymptote here. If you're doing, I don't think I said this yesterday, if you're doing just a sine graph or just a cosine graph, where do you put the asymptotes? If it's just sine or just cosine, you guys know? You don't put them. There are no asymptotes. Okay, it's sine and cosine are never undefined. Okay, and then we have this go away for our secant graph, and away from the x-axis, and away from the x-axis. Any question on that? Nothing new. That's what we did yesterday. Okay, so yesterday we did vertical stretches. Now we're going to do vertical slides. Okay, so let's go to algebra. If I give you y equals 3x. If I graph that line, and I give you y equals 3x minus 4, what would that second line look like in comparison to the first line? Down 4. What if I put plus 4? Let's go up 4. It's the same graph, up 4. Okay? Same thing here, but we're not going to be graphing lines. We're going to be graphing trig functions. Okay? So, if I gave you this right here, and again, these are going to start out not so bad. They're going to get tougher. I would say probably, I don't know if we're going to even when do we start tomorrow with games? Do they start at 1? At 1 it is?
That's what I heard.
So,
We'll get through
do you guys want to do trig tomorrow? Or you guys want to do something? Okay, we'll probably take tomorrow off. I'm not going to make you do trig on, because normally it'd be 12:15 is when you go to games, but we're doing it later because there's no parade. So I would say probably next Tuesday is when this is going to get really tough, okay? And I don't want anybody sitting there going, oh man, I'm kind of confused right now. Ask questions then, okay? Because it's gonna get even tougher. It's really important that you get this down, the easier stuff down, because when you get to the hard stuff, it gets really tough. So if I give you this right here, y equals sine of theta plus 4, okay? I would really encourage you do this, okay? Now, you should be able to tell me it's going to be a sine wave, but 4. It's going to be up 4 spots, okay? That's fantastic. But what I would encourage you to do is this. I'm going to write this down. I'm going to show some work on this. Okay? Any idea what that V is? What V stands for? Vertical. Vertically, it normally fluctuates from 1 to -1. And that's what it does. On a regular old sine graph, now, if this was a 5 right here, I wouldn't have wrote -1 to 1. I would have said -5 to 5, okay? So -1 to 1, but we're not ready to graph it yet. We're going to move it up 4. So you know what I do to this and I do to that? Add 4, add 4. So vertically, it's going to go from 3 to 5, 3 to 5. So, and don't do this, okay? I'll see students go, it's technically not wrong, but it looks weird. I mean, what do we call numbers below the x-axis? They're negatives. I mean, where should 3 and 5 be? They gotta both be positive. They should be up here. So, here's 3, here's 5, okay? And then, we put 2 pi here, 1 pi here, pi over 2 here, and 3 pi over 2 here, okay? Now, I would encourage you to do this, and I'll give credit where it's due. Every now and then a student will say something that I'd never thought of, and I say, you know what, I'm going to bring that up whenever I talk about this again. Jesus, is terrible. Not KFC. Summer Thorpe's oldest sister. Her oldest sister, Danny Thorpe. If you guys know who Danielle, but she goes by Danny. When I had her in trig, she noticed this, and I was like, yeah, I'm going to use this. And what I'm getting at is this, and I give her credit for it. Between 3 and 5, we know it's 4. She said, Mr. Kao, is that number always going to be that number? And it is. It's always that number right there, okay? And I never thought of that, so I'll give her credit there. So if you ever come up with something I never thought of, I'll give credit to future classes about that, okay? So, a sine graph, we know starts right in the middle, right here, not down here because we moved it up 4, okay? Now, where are we going to be at pi? Are we going to be down here at 0? No, we're going to be up here at 4. And at 2 pi, are we going to be down here at 0? No. A sine wave goes bang, 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 right in a row. Those 3 spots, first, third, and fifth spots are all right in a row. Where are we going to be at pi over 2? Up here at 5. It's a regular sine graph, not a negative sine graph. Sine graphs go up and down. At 3 pi over 2, we're going to be at 3. And that's it. That's all you got to do. Now, it looks like I scrunched it down because normally I say this much is 1 and this much is -1, but it's as long as you put the hash marks, it doesn't matter, okay? It's not drawn to scale. It's like a map, okay? Maps are not drawn the same sizes of what it is you're mapping out. Now, one thing also, I'm curious about this. This is one cycle of a sine graph. I mean, how many cycles could I draw?
A lot.
Like 10?
Probably more.
How many more? 100?
There's
I can put as many as I want, okay? It goes on forever. And I'm curious what your guys' thoughts are on this. Since it goes on forever, should I put arrows on these?
No.
Why do you say no? I'm not saying yes or no. And I want a good discussion here. You say yeah or no?
Arrows signify that it's going in one direction forever.
Right. So answer this. Does it stop? Does this stop?
No.
No, it doesn't. How do we normally indicate something doesn't stop? We put arrows. But you're saying no, we shouldn't because that's indicating it's going to go like this forever. So I take either argument. I don't know if there's a correct answer to that one. So here's how we alleviate that though. I want one cycle. If you only have one cycle, should I have arrows on it? No, it should only have one. Okay? Because it does go on forever, but it doesn't go up forever. Okay? So that's it for that one. Let's try this one. Y equals negative cosine theta minus 3. I would really encourage the first thing you do is put down V, negative 1 to 1, but do what to those values? From which one? Both. Negative 3, or minus 3 to each. So vertically, it's going to go from negative 4 to negative 2. So we put negative 2 here, negative 4 here, And halfway between -2 and -4 is -3, that number. We put 2 pi, pi over 2, 3 pi over 2. Does a cosine wave start right in the middle?
No.
Either high or low point. In this case, is it high or low? Negative means we start down here at -4. We're going to end at -4. Wherever we start, we have to stop at. Where are we going to be at pi? What's the high point? What's the highest this thing ever gets to? -2. And where are we going to be at pi over 2 and 3 pi over 2? -3 in the middle. And again, it's really tempting to make it a V or even make it a parabola. It's not. It should go like this, and the opposite way, this, and the opposite way. Any question on that one? Yes, is your hand up? Can you hold off like 5 minutes? Okay, so I gotta write your pass and yes, sir.
We do a test, does it matter how we draw it?
Tell you what?
Like, if we accidentally draw it wrong, are we gonna get points off?
Draw it wrong?
Yeah, how you were just
Okay.
saying to.
Like if he doesn't
Ah.
make curves, he makes straight lines.
Don't make them straight. These are, I mean, there's got to be some curvature to it, okay? And, I mean, I see every year I'll see this. I'll see students do this. They'll have it kind of arcing this way and that way, and like, I mean, that's really close to looking like a parabola. And it's not a parabola. I mean, it's not. I mean, it's like if I gave you this right here, y equals 3x plus 1, and you make that look like a parabola, that's a line. I mean, it is. There's no, it shouldn't have curvature to it, okay? I mean, this isn't art class, but it's gotta be,
Somewhat.
yeah, it's gotta be close, okay? I mean, my graphs aren't that pretty. This one looks pretty nice. But, yeah, it's gotta be, I've seen your handwriting. You'll be okay, okay? So, all right, let's try a few more and then I'll let you guys work on some of these. Now, let's get a little bit more difficult, How about y equals, -6 sine of theta plus 2. Okay, let's do this. Again, I wouldn't even start graphing this thing right away. I would make some notes to myself. So I'm going to put v. What am I going to write? -1 to 1?
-6.
-6 to 6. I'm going to make one more note to myself. What's that negative? You don't have to write this down, but I would. What's that negative going to do? Flip it. I'm going to write the word flip, because if I don't, you know what I might forget to do? I might forget to flip it. Am I going to mark you wrong if you don't put flip down? No. Just don't forget to flip it, though. Okay? But I need to add 2 to both of these. So it's going from -4 to +8. Okay? Now we're ready to graph it. So we got -4 to +8. And what's halfway between -4 and +8? +2. Okay? That number right there is always right in the middle. So we have 2 pi over 2, 3 pi over 2. Where does the sine graph start? Right in the middle. So at 0, 2. Where else are we going to be 2 at? At pi and at 2 pi. Where are we going to be at pi over 2? 8?
Low point.
We flipped it, the low point. 3 pi over 2 are going to be up here. What if I changed it to the cosecant? Did I just screw up and I had to erase all this? Would we want to keep any? Would we want to keep any of it or all of it? Keep all of it. Now you got to be careful on this. Where am I going to have my asymptotes at this point and at this point where it hits the x-axis? Not this time. Not when it hits the x-axis. Not at 0. 0 is the x-axis. Where it hits what? 2. Where it hits 2 because we moved it up 2 spots.
Yeah.
So it's going to be undefined wherever it's 2. So we're going to put it here,
Pi.
and at pi, and at 2 pi. And it goes away, it goes away. Okay? That's got to be careful on that one. It's not always, when you start moving them up and down, it's not always the x-axis anymore. Let's try one more. Let's see if we can do this. Let's do y equals -8 secant theta minus 5. Okay? We're going to make a cosine graph first. I'm going to put in parentheses cosine. Okay? So, vertically, -8 to 8. We're stretching this thing out. But, subtract 5 from each. So it's going from -13 to +3. Okay? So,
Are you gonna flip it?
yep, negative right there. If I forget to write that down, is that okay if I forget to write it down?
Yeah.
Yeah, just don't forget to do what it says. Okay, so we have 3 right here, negative 13 here. What's between 3 and negative 13?
-5.
Negative 5. And like you said, just to make it easier for yourself, I mean, did I put negative 5 on there?
Yeah.
Yeah, but where should it be?
In between.
Pretty darn close to the middle of these two numbers. That's just gonna make it more confusing for yourself. Put it right about here. That's closer to the middle. And then we put 2 pi, pi, pi over 2, 3 pi over 2. Okay? Occasionally I'll have a student ask me, well, what if we forget to put these hash marks on here? Then it's totally wrong, okay? When I grade these, you know the first thing I look at? The hash marks, okay? The last thing I look at is the graph. The hash marks is the hard part. Once you have the hash marks down, the rest of it's easy, okay? So, we start here at 0, negative 5? Or not?
No.
I thought we started right in the middle.
That's
Not on a cosine graph. On a cosine graph, you start at the high or the low. In this case, it's the low. We flipped it. Okay? We're also going to be at negative 13 at 2 pi. Where are we going to be at pi? The high point. And where are we going to be at pi over 2 and 3 pi over 2? The middle.